Welcome to this exam question on linear graphs. Okay, we're looking at parallel and perpendicular lines. We should be familiar with the general equation of a straight line, which is y equals mx plus c, where m is the gradient and c is the y-intercept. Okay, there is another form which you may be familiar with, where x1, y1 is any known point on the line, and m is its gradient. Okay, y minus y1 equals m brackets x minus x1. And that simply comes from rearranging the formula for finding the gradient, which is the change in y divided by the change in x. We'll look at that afterwards, but we'll start with using this only. Okay, so in part A, we have this to do. We have a line which is given in the form 2x plus y equals 8. Okay, I want to put that in the form y equals mx plus c and do a little sketch of what's going on here. All right, always a good idea. So for L1, I'm just going to rearrange it slightly, and I'm going to say it could be written as y equals minus 2x plus 8. Okay, just by taking 2x from both sides. So it has a gradient of minus 2, crosses the y-axis at 8. So let's just sketch that on our axes. So it's something like this. It's going through 8, and it's coming down with a gradient of negative 2. So that's the line that is L1. Okay, and it's crossing here at 8. This is the y-axis and x here. Okay, so this is just to help visualize what's going on. Now we have a line parallel to this that goes through the point negative 2, 5. Well, on my scale, this is 4, so 5 is about here, negative 2 is about here. So we're looking for a line that goes through this point here, okay, and it's parallel to this one. So we'll put that in a different color, and this is going to be L2, and it's going to be roughly like this. Okay, oops, I'll use the straight line function here, and it's going to be roughly like this. Same gradient as that one, parallel to it, doing something like that. This point here is the point negative 2, 5. Negative 2, 5. Okay, so we're just having a visual representation of what's going on. Right, okay, well, there's two ways you can do this, as I said, but I'll use this first. So at L2, okay, I can say that at the point, well, it has an equation of the form y equals minus 2x plus some constant. All right. The reason I know that is because it has the same gradient as this one, L1, because it's parallel. All right. But it cuts the y-axis at a different place. So what we can now use is the known point. So at the point that we're given on the line, which is negative 2, 5, okay, we can say that y, the y coordinate, which is 5, equals negative 2 times the x coordinate, which is negative 2, plus some number c that we're going to find. Well, that's quite simple to solve, because that's minus 2 times minus 2 is 4. So 5 equals 4 plus c. Okay, so 5 equals 4 plus c. Okay, which implies that c equals 1. Okay, and so the equation for L2 is y equals minus 2x plus 1. Okay, so we use the known point on the line to find the value of c, the constant at the end. All right, Now, using this method, we could have just gone straight to this instead. So I'll just write this down underneath. We could have just used this, y minus y1, y minus, and y1 is the known point on the line, the y coordinate of the known point, which is 5. So y minus 5 equals the gradient, which is -2, and then it's x minus the x coordinate of the known point, which is x minus -2, okay, which is the same as x plus 2, of course. Well, if you just tidy that up, you get y minus 5 equals -2x, and this becomes here plus 2 times -2 there, which is -2x minus 4. Okay, now if you just add 5 to both sides, you get y equals -2x plus 1. Okay, so it's the same answer, and you can just directly substitute into this equation instead. So it's an alternative way of doing the same sort of problem. All right. Okay, so going to part B now. We'll look at part B. I'll just partition this off here, give us a bit of space. Okay, so in part B, I'll do this line in green. L3 is perpendicular to L1. That means it's at 90 degrees, and it crosses it at the point 2, 4. So again, we know a point on the line, L3, but it also happens to be on L1 as well, which is fine. Okay, we've got to find the equation of L3. So first of all, let's do a sketch. Well, it crosses it at the point 2, 4, which is going to be about there. Okay, and it's perpendicular, which means it's at 90 degrees. So it's going to go through that point there, something like this here. And this is only a sketch, so it's not going to be accurate, but it's going to give us a rough idea. And that's roughly correct. So it's crossing at 90 degrees. So I'm just going to put a little right angle in there. And that point there is the point with coordinates at 2, 4. Okay, and the green line is the line L3. Okay, so we've got an idea of what's going on there. Now, the gradient of L3, the gradient is the negative reciprocal, okay, of the gradient of L1. The gradient is the negative of 1 over -2, which is a half. Okay, so we know that the equation of the line L3 must be of the form, okay, for L3, y equals a half x, because the gradient's a half, plus some constant c. Okay, I'm going to call this, actually I'm going to use a different letter. I'm going to use D because I used C in the last question. It wouldn't matter, but it's better, I think, to keep it separate. So I'm going to call it D. And I know that it goes through the point 2, 4. So I'm going to say at the point, okay, 2, 4, I can say that 4 equals a half of x, which is a half of 2 plus d. Okay, well, a half of 2 is 1, so 4 equals d plus 1, or 4 equals 1 plus d, to keep it in the same order. Okay, well, therefore d equals 3. Okay, d equals 3. So the equation of the line L3 is going to be y equals a half x plus 3. And if you look at our diagram, it seems to be crossing the y-axis at about 3. Okay, remember it is just a sketch, and it's got a gradient of a half, which again looks roughly correct. Okay, so that's the correct answer to the question. If you'd wanted to use this formula instead, you could have just done so like this. You could have just said that y minus 4 equals a half, okay, because that's the gradient of x minus 2. Okay, I'm just basically replacing the x1 and y1 with 2 and 4, you see? And just rearrange that, you would have got y minus 4 equals a half x minus 1, because a half times minus 2 is minus 1. Add the 4 to both sides, and you would have got the same as we got here, y equals a half, sorry, the same as you got here, y equals a half x plus 3. Okay, so that's alternative method. If you want to learn that and use it, that's an alternative way of doing it. Okay, so that answers each of those two parts in two different ways. I hope you find that helpful.